Thank you everyone for being here. My name is Anna. I do integrated circuit design at D-Wave, and I'm also really passionate about democratizing quantum technology and making this a more inclusive and welcoming place for everybody. So, yeah. I think you can read all about me on the screen behind me. I will not reiterate that. But yeah, I have a master's degree in electrical engineering from UBC. I was part of their Create Quantum program, which was a wonderful program. And then I've gone on to do several industry jobs, most recently at D-Wave. And in my spare time, I do a lot of events like this and build a lot of courses and try to engage with the community. So as part of this panel, I'd like to welcome my panelists to the stage. So we have Dr. Daria Arnsmeyer, Chloe Malbruno, and we also have Dr. Ulrike Steiger. You want to come up and take a seat? Okay.
It's on.
It should be on. I think I turned it off initially, so. All right. So just so everyone gets to know you, would you just quickly introduce yourself and say a little bit about yourself before we get started? You want to start, Daria?
I'm waiting for my slide to come up. Yeah. We thought we'd put some visuals there for you to look at and also to focus our thoughts. And since this is an international event, I put a lot of pictures there of all the places that I've been to. I'm from Bielefeld, Germany. It does exist for those of you who have seen the story a few years back about it not existing. Yeah, see, some people heard that. I studied physics there, became Diplom-Physikerin. I put some German words in there because they're nice and long. I also did my PhD there in theoretical particle physics because I was not allowed to do quantum information. That's the story. Then I moved on to some postdocs in Winnipeg at Lawrence Berkeley Lab. Then I had some more stations at Trent University and the University of Calgary, where I did teaching, course development, and physics education research. And then I joined SFU, first as an educational developer. That is an interdisciplinary job, working with people who teach in all disciplines about how to teach and how to develop courses. And now I am in the physics department as a faculty member, teaching a lot of quantum and other stuff, and starting quantum education research with funds from MITACS and Quantum Algorithms Institute. We are very excited about that because it's a very new thing. And I also put the logo of Quantum BC there, which is our nice network across the province from all the 3 universities and Triumph, and it's growing. And the Canadian Association of Physicists, in which I've been active since pretty much I came to Canada. It has been my physics home away from home. I've been chairing the division of physics education first, and then I thought we need a new division on quantum information, so I started that one, and we have that one now. I'm showing you this because I want to show you 2 things about me. I am very much interdisciplinary. Learning from different fields is, I think, something very valuable that brings us forward in many things. And I find the community engaging with other people very important. And I see it's very important for our students as well. I find that they succeed more when they are part of the cohort of the community. Thank you.
Okay, so I'm Chloe Malbruno. I'm also waiting for my slide to appear. So I'm a research scientist at Triumph. I did my education part of my education in France. So I followed the French system and did Grande École in France, so undergraduate at the École Centrale Marseille, and then moved on to do a double master. So there was a very nice double master degree with other European universities. So I went to Vienna to do my master in physics, and then I came here at UBC for my PhD. So I got my PhD in 2012 in particle physics at UBC, doing an experiment, a particle physics experiment here locally at Triumph. And then I went back to Europe to do a postdoc at the Austrian Academy of Science, based at CERN, and then I stayed at CERN for 10 years, first as a research fellow and then a research staff. And then, 10 years after leaving Vancouver, I came back as a research scientist at Triumph. I just wanted to highlight a bit my research so that you see the connection to quantum. For 10 years at CERN, I was actually working on high precision spectroscopy of anti-hydrogen atoms, so atomic system, looking at basically in the quantum sensing realm, and also developing new tools for searching for a new elusive particle called the axion, using quantum techniques. And more globally, so I'm also rather multidisciplinary, having particle physics background and also working in atomic physics. But globally, I'm working on low energy, high precision experiments. And I've been also quite involved in outreach. While at CERN, I participated in TED-Ed animation on antimatter and did some podcast. And over the year, maybe 6 or 7 years, participated to the UNESCO's program of International Day of Women, Girls and Science. And here I learned a lot. Maybe we'll address some part of it on diversity in science from this experience. Thanks.
Okay, hi everyone. My name is Ulrike Stege and I'm currently faculty member at the University of Victoria. So I started out in Germany, where I was born and then became a diplom mathematiker. When? Okay, wow, okay. After maths, I went to ETH Zurich and did a doctorate in computer science. My research from the start has been in a mix of theoretical computer science, algorithms development, problem solving, but I've always been fascinated in interdisciplinary research. And those problems that are out there, a bunch of them, they are what is called in classical computer science hard or intractable, meaning you know how to solve them, but you need too much resources or so to do it really well, or particularly for large data sets. And I'm still interested in solving those, and that's how I got into quantum, but we can talk more about that later. So after my PhD, I went as a postdoc, as a PIMS, Pacific Institute of Mathematical Sciences postdoc to UVic. And I'm stuck there since, now faculty member, and faculty member since 2021, so, since 2001, okay, there we go. And so I have done outreach, actually starting my time in Switzerland, I've done a lot of STEM outreach. And so there is at ETH, I think they still exist, I haven't checked again, but a couple of years they still existed. Founded with 3 other female colleagues, PhD students there. We founded a Mittelschülerinnen-Tage, which is for middle school girls. And so that was a really fun event and to get that started. And it's so impressive that it existed for so long, and I think still exists. And then at UVic, I've been involved. We founded several outreach groups, some for younger ones, and then also for high school students more recently. And once I was in quantum, which started end of 2018, 2019, we also organized quantum events, quantum computing events for you. So as you heard, I'm not the physicist here, so I'm coming from the other side. So this is one of the science quantum is ready for quantum computing, and so it's a very exciting area to be in, which is still growing and relatively new. Also, maybe one more thing, outreach also or education. I'm also we developed a quantum software engineering boot camp, and support with QAI. There's some QAI folks here that I'm just working with that right now to take this to the next level, which is really fun, and so one of our students doing a lot of work there. So there's a lot of different events in education. I do initiatives I follow in addition to the research program that's going on. Okay.
Wonderful. So I'm going to just get started on my questions here, and feel free to jump in at any point. Not everyone has to answer every question, as I think I've mentioned before. But yeah, so my first question is, what were your perceptions of careers in quantum science and technology? I'm especially curious about how your journey into the field went and what got you interested in quantum science initially.
I can start since I was just talking. So, for me, it actually happened kind of in 2018. So 2018, there's this IBM conference, CASCOM, which is a Canadian event and happened every year in Toronto, and we went there regularly, and it was really great for students to get experience. And they had this quantum computing workshop as one of the events that they organized there. And Mehdi Bozoreh, he led that workshop at the time, and I sat in, and I thought, why not? Let's look at that. And that was the time when the early IBM machines were accessible on the cloud, and they had this nice quantum composer that is still available in a just much better version. And so we got some intro and what you can do and how it works a little bit, and he asked some questions, and I could answer question fast, which made me really proud. I won a t-shirt, so that's a t-shirt I still have. And so, I don't know, that event was really fun, and that was the same time I had been just department chair, and that term was ending, and sabbatical was starting, and so that was a time to maybe rethink what else you can do in research. What can I shift something? Can I add something to it? And that was the moment when I thought, okay, let's give quantum a try. And I did not think that was necessarily something I would really end up in, but I wanted to explore what we can do now. And so I'm still stuck in there. So that was my journey into that.
Okay, sure. From my side, I think this was third year undergraduate when I first came to hear about quantum mechanics. I had a quantum mechanics professor who had an interesting pedagogical approach, so he would never look at his audience, only at his whiteboard, and the whiteboard was full of equations, and then he just would go through the equation. And so when he said, okay, if you don't like my lecture, just take a Ciocoiu book, who was basically the Bible for quantum mechanics. Anyway, all my slides are taken from there. And yeah, I think it's thanks to him or because of him that I actually went and looked in detail in this book, and it was like just fascinating. And we had in undergraduate, we had all the material to for our studies, but I wanted to buy my own version of this book, and I think that's the first book in physics that I wrote, and yeah, it really, I discovered a new word through these books, and that really made me decide to go into physics, and then afterwards I had a particle physics lecture, and I said, okay, that's what I want to do, but that was really the thing that decided, going for quantum.
Quantenergia.
Quantenergia.
Okay. Yeah, I come from the physics side, not the computing side, and when I was about 15 or 16, I wanted to study math, because it's pretty cool, and then I discovered, oh, you can apply math to the real world, and it's called physics, and I enjoyed that even more. We had a really good physics high school teacher who got us talking about topics we were interested in, including particle physics. I got a whole package of materials from CERN back then. They were beautifully made, and then I was hooked. I wanted to do particle physics. And then I learned there is something even more interesting, that's quantum physics, in about second year or third year. So that's how I got hooked. And then I have something that I think goes into the next question that you prepared for us. When I wanted to do my master's, when I was going to do my master's, I wanted to work on what we would now call quantum information, entanglement measures. And I was told, no, you should not do that, because that's only philosophy, you will never get a job with that. That was years after the BB84 protocol. But that's how I settled, no offense, for particle physics. And then it took several years to get back to doing quantum from a different angle. But do we have anybody from the German consulate here? No? No, maybe it's a bit of a German tendency to be a little bit careful with innovation and new things coming up. It's getting better now. But yeah, that was sad at that time.
Well, it's nice you found your way back. I also wanted to ask you, to tie into the first question, whether you felt that you had adequate mentorship and support on your learning and professional journeys.
Okay, so for me, mentorship for quantum was different because it was so recent, right? So and it was not just my sabbatical; it was also the pandemic hit there. So it was a special situation. I can talk about this a little bit more, which it was actually really fun, really good, because thanks to the internet, there were so many people available. But during my studies, going back, starting with math and then computer science, I think I always was lucky to have the right people around me that supported me. And while there were not that many women in computer science at the time, particularly when I did my PhD for math, there were quite a few, maybe not so many female professors, but there were a lot of role models around me. In computer science it was a little bit less, but there were great mentors who took us on as female PhD students. Without those, I don't know, but thanks to those and the combination of people, in the field and the ones, who were role models as women, etc., it worked well. There was no real official mentoring program that applied to me, or I noticed at the time that happened. I think having supportive people who understand situations and I think are good in spotting talent and being supportive, giving you advice, giving you opportunities. For example, how did I end up in Victoria? Because of opportunities. People told me about this, right? You don't just know about the PIMS postdoc opportunity just like that. You know somebody who encourages you to do these things. And yeah, that was kind of my journey. Did that answer the question?
Say a few words as well. I don't think I had specific mentorship programs either through my studies, but I definitely had mentors through my professors and supervisors, etc. And maybe interestingly, I think my view on mentorship evolved since I was myself a student to now when I am actually mentoring other people. Back then, I didn't see at all mentorship through the lens of identity or diversity, so I thought, okay, mentorship is all about science. The only thing we have to think about is how to do the best science, and this is why supervisors are here and mentors. But in fact, I think that's not true. A lot, and I faced this later on, realizing that actually our identity is maybe fortunately and unfortunately part of also our work as physicists, and where actually I think back then probably my mentors and supervisors were also realizing this and probably oriented me the best they could in the current system, right? But now I came to realize that a lot has to do with trying to define and deal with one's identity through physics as well. And maybe we can develop this point. I think you have a few other questions but I have a different view now on mentorship than I had when I was a student.
Okay, now how do I focus? Similar to what you had been talking about, I had no awareness of mentorship. That's a thing that's needed, that would be helpful. And only years later, I realized that I had no role model. I'm not the type who wants a role model, but it took me, I think the second year of my PhD program, that was the first time I saw a female physicist, I realized later. I didn't know that I didn't have seen one before, I didn't realize it. But some things, you can't overlook. When we started our program, and there were 100 of us in the first year, there were 3 women. One of them dropped out after 2 weeks. The second made it to the master's. And I think I was told I was the first woman to do a PhD in radical physics in my department, at my university. I think to this day they do not have a woman on staff, on faculty there. Sorry, I don't mean to ruin the mood, but that's just an observation. And that has effects on your everyday life, because when you sit in your lecture hall and the professor greets you by, "Good morning, miss, good morning, gentlemen," that's noticeable, right? You're always sticking out like a sore thumb, and you're kind of an antenna for the few people in each population that are a problem. I want to say very explicitly, I do not believe that physics or computer science or engineering is any more hostile to women than other fields, not in my observation. The problem is the numbers, because in any population you have some problem people, and when they focus on the small number of women who are there, that gets awkward. Now, on a positive note, since I moved to Canada, I found people to be a lot more supportive. I don't know if it's the Canadian friendliness that works better, and I do enjoy mentoring students right now, because it's very interesting to see what people can do if you work with them, especially people from different backgrounds, and backgrounds, whether it's discipline or country or language or whatever they're coming from. So I'm very much enjoying that.
Well, thank you. So the next couple of questions are designed to answer, I think, the question that we're all here to answer today, which is, how do we address the talent shortage and make quantum more accessible for everyone? So feel free to answer if you feel compelled to do so. So my first question is, graduate school stipends in most of the world have really not kept up with the cost of living, especially in cities that are experiencing a housing crisis right now. And so this is increasingly making graduate school the domain of the independently wealthy. So how can we move towards a more equitable funding model and enable students from more diverse financial backgrounds to pursue degrees in quantum science and technology?
So I think, well, yes, so there's the one problem that is a general problem, what Anna just mentioned. Life is expensive, and for students in particular, and this is getting harder, it's really a problem, and I think it's the same that applies to no matter where you go. But in quantum, we might have right now some special opportunities, because it is an emerging field, and quantum computing in particular is, there's a lot going on right now, and there's a lot of opportunities for students to educate themselves in advance because of the amazing resources that are there via the internet. So there's a bunch of companies giving amazing resources, free summer schools. There's all kinds of things you can do to qualify yourself and get up your CV to maybe get those scholarships. For example, the great program you were a part of, and that we at UVic with UBC as a view, we have this great program that's unfortunately running out soon, but we had a whole bunch of amazingly talented students in there. And in our group, for example, we had a bunch of women, and there were much more, so it was a really nice talent to see. And so these kind of programs, they help the faculty in Canada to top up, to pay them a bit better, pay them a bit more. It's still not enough money ever, right? You need so much more for living, but I think it helps to reduce the extra burden of having too many extra jobs, etc. So in general, I think quantum computing in particular is an area where I see more opportunity for that. I see more opportunity for diversity right now because it's newer and it's easier to get that started. So I think we can still make this happen in quantum computing, that we have a really diverse crowd. Not everyone who gets into quantum computing has to be from physics, they can be from all kinds of areas, etc., and they're accepted to those programs, which we saw with our CREATE program. So, yeah, on that note, I hand it over to Chloe.
Yeah, no, I think indeed, I mean, the issue of not enough funding for graduate students is clearly a risk to lose talents, right, to other, maybe to industry, or so. And it's not. I mean, it's good if people go to industry for sure, but we need to make sure that we have the funding to support people into graduate studies from different backgrounds and who need to be able to live on those scholarships. So that's true, and I think there is now a path to improving things, which I've started recently, so that's very good. One maybe topic addition on the diversity side, I really liked, maybe I hope I'm paraphrasing correctly, Shohini Ghosh from Laureate University was saying that there was really an opportunity with quantum, maybe quantum 2.0, of creating a new, a new, more diverse way of doing science, just because of the essence of quantum physics, right? Quantum physics is based on uncertainty, not necessarily knowing everything, and that could feed more into society somehow, and so that people approaching physics in a different way, in a very different way that maybe usual physics or Newtonian physics or whatever was about being rigorous and knowing everything, and in fact quantum is much more about not knowing things. And she was seeing an opportunity for things to change, also to become more inclusive from this point of view, and I thought that was an interesting point that really relates to quantum versus maybe the rest of the science.
Okay, I'm going to ask her about that. Regarding the funding, we hear that a lot from our grad students that it's getting difficult, especially in Vancouver, with the cost of living. I seem to recall there were some protests last year that actually succeeded in getting the answer funds up. So that is good, because it's a countrywide problem, right? It's not something that one university or one research group can address.
Wonderful. Thank you for your answers. So my next question is about representation. So students from underrepresented groups have been found to be, by numerous studies, more academically successful when they're taught and mentored by those with similar backgrounds. So often faculty members that identify as part of these minority groups shoulder a lot of unpaid responsibilities, such as informal mentoring or chairing DEI committees, and this diverts time and resources away from research and other tasks that are critical for securing tenure. Are there programs and initiatives that you found to be successful at any of the institutions you worked at in addressing this problem? And if not, what are your thoughts on programs that might be successful?
I think I want to go back to CREATE, the CREATE program, and just having seen it with our own students, the excitement they got because they have this mentorship program, there are these industry volunteers who serve as mentors, and my students are so excited about the meetings with their mentors. It is so cool. And yes, I know the unpaid parts of some companies may make it part of your workload and some may not. It is a problem if we have to volunteer extra things a lot. I think many of us know these kind of things, like even if it's on hiring committees, etc., because they need a representative of a group or something. But overall, I think they can work as long as there is a choice who is not just being from the same group is not enough, right? You need to have a good fit, and maybe you need, as maybe we had more mentors that serve different purposes. But having people being willing, now in the quantum community being willing to help and to support, and I think we have a lot of them. It looks like they exist because there's a lot of excitement and see the talent who wants to get into this. I think it's there. We should take the opportunity and we should recognize it. So it's really important that we recognize these tasks that people take. But I see it helping in many occasions. And however, I do not know many official mentoring programs in general that go on for years and years. I think there's a lot of change needed with those kind of things. They change a lot, and so you have to update them. So that's my view, and at least I'm very happy to see this success right now with our quantum gang for this quantum PC. Yeah.
Okay, yeah, it's a very interesting question. I think there is many different points to it. Actually, the first time I really became as you said, right, it was clear that women are not the majority in science, in particle physics, in quantum physics. That was clear, of course, to me and to everybody. Right? But during my PhD, I came across a book by sorry, her name is Dona, no, not Dona, sorry, Schieberger. Anyway, a professor of physics at Stanford who went into gender science and was very advocating for equal treatments, and she had a very interesting book called The Mind Has No Sex, which really made me open my eyes on some issues, and I approach this really from a purely maybe intellectual curiosity. Okay, can we explain why the status is like this, and what brought us to having such a difference of interest between men and women in science and STEM in general. And then I participated to the second gender summit at the European Parliament in 2012. That was just before Horizon 2020, so something like 2 years before Horizon 2020 was launched in Europe. So that is a funding framework for funding science in Europe. And there were people reporting on the outcome of the previous European Research Council funding, so these ERCs, and how men and women did differently. And they really reported the fact that if you had 20% women application, you would only get 10% of the unsuccessful. So there was a clear bias, possibly, against women in these high funding programs in Europe. And so there was this author, and I'm sorry I can't remember her first name, who was there, so invited by the Gender Summit to comment on these results. And she said, I'm not very surprised. It's been seen, and people from the European Council were saying, we had 50% women on the panel. How come we can end up with such bad results? And she was saying having women on the panel don't necessarily help. Sometimes it's been shown that it actually doesn't help, and that women are tough on women because they see, women applicants with 3 children, and then they say, at my time I could not have a child. It was impossible to do science and have a motherhood and things like this. So she pointed out this, and the second point she pointed out was that going for 50% women on panel is it's not efficient, right? Basically all women researchers will have to be on panels constantly because they are just not 50% of women, right? And so she raised this problem of having an overburden on women. So I'm really here focusing on just on the gender aspect. But that's something that came out, and I think it's really interesting. Things like this, it's been clear, I think, that it's not about, in order to increase diversity, it's not about fixing, again, if we talk about gender, it's not about fixing girls to go into science. It's really fixing the society and the system to So it's more on the policy side that we have to do things. And having panels like this, raising awareness, I think it's very good, but we should have actually men on those panels, right? Because it's a society issue and it's not a women issue. That's
Very well said.
I think part of your question was, about what you just mentioned, that's an additional workload for people to be on panels, to be on selection committees, etc. Which is very similar to how service workers in general, and not that much valued in academia. So I think it's a general issue that should be addressed better. Maybe it's the point, maybe people need to point out better how valuable this kind of work is, and not just focusing on research 99% of the time. Might be useful for students as well, if they can point out more their soft skills on their resumes, for example. I've noticed that many students are not aware of how useful those skills are. Many students seem to be focusing just on the research and think that's what will get them a job, not realizing that communication and collaboration and these are the skills that are not just asked for by industry, but also by research groups. I see that with my first year students, of all people. If you explain to them, look, this is what industry is looking for, this is why we are training you in doing group work and communication, all that, they understand, and they practice, and they enjoy it. So maybe that's another thing we should focus on more. Another job that we need to do, yes, but I think it would be useful.
The list of jobs keeps expanding. Thank you all for your points. So the next thing I wanted to bring up is that research capacity in less resource settings depends a lot on students and scientists being able to read and publish scientific articles. And access to resources, especially for emerging fields such as quantum science, varies greatly worldwide. For example, there's language barriers, there's academic journal paywalls, there's all these barriers that inhibit research progress in a lot of countries. So what are some steps that you think can be taken at the institutional level to lower some of these barriers to research?
Okay, here comes the quantum computing side again. I mean, I know it's hard, and there are never enough resources for there, but I see some steps taken. I'm not saying this enough, but there's some great things. So, for example, a lot of us in quantum physics people, they publish their papers not just in those peer-reviewed places where there might be a barrier to access them, they are on archive. That is this publicly accessible source to publish. And most people use this in the meantime, which means you can easily get to the English articles. It doesn't help with the language, but language, we also have internet helping with other media. So as long as you have good internet, you can read those articles, you can find them, and you can see which ones are peer-reviewed or not. You can figure this out. You know, you have to make sure that, because there can also be articles that are not peer-reviewed, of course, and you have to be more careful. But you do have access to it. Now, conference access. So I guess the pandemic helped a little bit because we started doing things more hybrid. For example, IEEE Quantum Week, which was founded. Hausi actually is the man for that, so you should talk to him later on if you're interested. But it is started online and is now hybrid, and the low-income countries, people from there, they get an extremely reduced rate to join it online. So where others have to pay still a lot, it is a very small amount. How much is it for those $30 to access? So at least you have the access. Of course, it's much better if you can go in person, which is much more exciting, but at least you can do it, so this is great. And traveling is, of course, incredibly expensive. Hotels are incredibly expensive. All that is out of range. But there are opportunities, and I think there are more and more conferences who do this kind of thing, and I hope there will be more really, helping that those kind of groups to help, build the talent. Okay.
Yeah, I mean, I had the same point, of course, regarding the archive, right, where we can have access openly. On the question on the language maybe barrier and language hegemony, of course, it's really convenient to have all English in order, because science and quantum needs as much exchange as possible, and that's, of course, made easier if we have just one language. But there are many initiatives to have also papers and republish in like original language of the people who wrote them. So there are these sorts of initiatives, and that's maybe a place where language models based on AI can help, right? That's, I think, one place where that can be helping on that aspect. And just one last point, coming back on diversity, one problem of, or potential problem of traditional peer-reviewed system, especially for highly ranked journals, it's been shown that there is a clear bias. And so if we see that, there was recently an article published where Canada was actually seen as one of the worst countries in women publishing in high-ranked journals. So taking Nature Physics, for example, there was no woman, senior woman listed as authors or in Nature Physics, and while there is maybe 20% of women doing physics. And so clearly the talent is not represented in those highly ranked peer-reviewed journals here. And so that's something people should be aware of and think about. I mean, I don't have the solution and why the reason is, but maybe, fear of maybe targeting too high, or other maybe service works which make it, but yeah, we have to look for this and try to think about how to solve this.
Of course, I was going to say archive as well, because that's what we all live with. But that's just access to reading papers, and yeah, you can post them, but you cannot publish them in a peer-reviewed manner. And that's what people still need for their careers to take off, because when you are on a selection committee and a review committee, people look at how many publications the applicants have, and that sometimes gets a little bit extreme just into counting. Of course, people on those committees are aware that there are different rates of publication in different fields, like particle physicists have different numbers of papers than people in mathematical physics, for example. But for those people who cannot afford to publish papers, it's a problem, and I don't think anybody has a good solution for that. I was talking with people from the Canadian Journal of Physics, because I was on the board for a while, and they want to be as accessible as they can for everybody. They want to make it free, but they need to produce that journal somehow. So I don't know if that's maybe something for the funding agencies to step up and support this. I have no idea.
So while I find publishing costs in peer-reviewed journals tough for us, for all of us, because the funds we pay those from are the same funds we pay the salaries to our students, which we just discussed are not high enough. But I have seen for several of the journals that I have been working with that there are again some programs for low-income countries. So I don't know the ins and outs of that. I have not investigated that. How easily, how easy it is to do, but there is some support for that. So again, it's probably not enough, but there is at least a start. There is some awareness. So we have to just push this more, and so. But I'm sure there are not all of these that can afford that, but there are some big vendors who definitely do that.
Yeah, definitely the publishing complex plays a big role in making things much more accessible, and as you said, there's a lot of thoughts on how to address that, but it's a complex issue. So my next question is a little bit about societal issues and staying relevant. So there's a lot of discussion in the media about potential applications of quantum computing and quantum research to issues such as climate change, like that's the one I hear the most. But in fact, a large majority of what I have seen personally for terms of applications are largely defense and finance. And these are largely detached from the issues that are relevant to many in developing countries. So how can institutions support more socially relevant quantum research and engage with a more diverse group of people this way?
Okay, I was just in a PhD defense at IRIC where the application of quantum chemistry was climate change, in the sense that it was about materials that are better for batteries, etc. All kinds of other ones. Don't examine me on that right now. But I think in academia we have that still. And I think maybe in industry it's still a bit too early, in the sense that while quantum is evolving amazingly fast, at least that's what it looks to me, a computer scientist, a mathematician, how fast the hardware is progressing and what we can do, we still need better computers to achieve the real breakthroughs for speeding up drug development, for modeling these molecules, for coming up with better solutions. So we still need a few years. Don't know what they exactly are, but I think that will make the difference. At this point, that might be just a bit too early, but that is just my uninformed opinion on this. That's how I see it.
Oh yeah, I think I would tend to agree that maybe there is a difference between what we see outside academia and fundamental research as maybe being used, and the publicity which is around, and the work which is actually going on in academia and fundamental research. So I think there is for sure application that can be addressing more the large issues that are coming up for the humanity, and where we can use quantum. And one example that comes to mind, especially what you mentioned about batteries, and these are things that are going on at Triumph as well, on quantum materials. And for sure there are a lot of applications coming up here. Maybe they are less publicized, but the academia world is working on those ones.
I was going to add another angle from my observation. The students, at least they're coming from the physics side, they don't really go into the field because they want to save the world. They just find physics really cool. They're fascinated by the content, they want to do that. And if there's an interesting application coming out of it, great. It might be different with students that are coming from the engineering side. I see that a lot of the sustainable energy engineering students that I teach, they want to save the world and make the world better, and that's great too. So I think we can attract different kinds of students coming with different interests. That's fine. But something that I've been trying to do for a while without getting anywhere, QAI, are you there? Promoting some toy model tasks, some proof of concept things, where you take a topic that is relevant to people in a real world problem, but solve it just as a proof of principle, just as a toy model. And that maybe with an academic partner who can't pay much because they're not a company, but who are interested in creating something that can be a first step towards more complicated things. Because I know that industry, companies don't want to do these, they don't want to reveal their secrets, they don't want to put much money into it. That's why I think this is something that academia and something intermediate like an institute could take on. Just saying.
Thank you. That's a great perspective. I just quickly wanted to share my perspective on this question because I'm an engineer and I want to save the world. I think that the more international projects and cooperations and partnerships we have, the more likely we are to create change on these sort of issues. I think, especially right now, there's a very nationalistic current in politics and in the world, and Everybody has their own national quantum strategy, and they're laser focused on that, almost to the detriment of everyone else around them. And I think events like this make me hopeful that we will have this collaboration and this humanity come together to work on these incredibly pressing issues. That was just my piece. I know I'm not a panelist, but I have opinions. Okay. Are we good with that? Yes? Okay. So my last question is a bit more about the quantum workforce specifically. So obviously we've talked about commercialization of quantum technology, and we've seen how it's accelerated a lot in the last decade. So we've seen this new quantum workforce emerge, and there's workforces filled with people who have joined the field from a variety of very different backgrounds and cultural backgrounds as well. So how do we support the education and ongoing training needs of this quantum workforce?
Okay, I have opinions on that. So, I would like to, so quantum computing, which is just a part of quantum, of course, quantum technology, etc. But I think it's a really nice entry point where you can, when you've started with quantum computing, you might go in all directions from there. And I mentioned in the beginning, we have done outreach for youth in quantum, with high school students. So you can start early, and so in my opinion, we don't have enough quantum computing, and for example, in undergrad. We don't have in general enough quantum maybe in undergrad. In physics, I know there are quantum courses, different kinds, quantum physics, quantum mechanics, but bringing all these things together, I don't think we have enough. And for example, at UVic, we have this, in computer science, we have one course. That's our course on quantum algorithms and software engineering. But it's a fourth-year course, and but it's from the prerequisites is relatively accessible. You need to know something, but many students in other disciplines in science, like in biology, in chemistry, in physics, they have some programming, for example. Not all of them, but many. They do have, for example, they do some computer science already. Why don't we integrate this into that, or have a second course and give people the option to start it early? I don't want to have to start in fourth year, I want to start this earlier. Most quantum computing education, or quantum education maybe, is still in grad school. I think we need to start earlier and then advance it in grad school. But I want to see more people with an undergrad degree also already enter the workforce in part of these areas. I think we have the capabilities, we just need to change our universities to put more effort into these programs. And so if you have anything to say to our administrators to push that, please help.
I think quickly, I do think that Université de Sherbrooke in Quebec has a quantum information and technology undergrad program that is starting. So there's signs that it's happening.
Yes, it's starting. Thank you for bringing that up.
Yeah, I think also large laboratory have a role to play here, like laboratory like Triumph, right, which basically bridge the scale from university lab to industry lab, right? So you have industry size, scale of equipment. Talk about large cryogenic equipment where engineer, technician, or people to be engineer, technician in those fields can be trained in cryogenic technology, which is needed in quantum applications, right? So here, and also this I think national assets like Triumph is a perfect place where fundamental science can meet all these application in technologies. So I think here, those labs have a role to play in building the workforce, the quantum workforce of the future.
I think it's both a challenge and a great opportunity because of the interdisciplinarity of the field. We need teaching tools, methods, content that works for people coming from those different backgrounds, and that's not easy to do. But figuring out how to do that well is a great opportunity because we see the diversity in all other kinds of our fields that we are teaching as well. So learning how to teach people coming in with different levels of preparation, different interests, different skills would be, in general, a very useful thing to do. The problem is it costs money and time. We need some professionalization of teaching. Most people do it, as an afterthought after their research, because they're most people, not everybody, because they're very busy. They have to produce results. And it requires a lot of time and thought and planning to do teaching well, especially if you want to address a new population of people with new content, and that content is changing on an annual basis or faster. So that's what I mean by a big challenge, but it would also be really interesting and probably have some spin-offs for other fields as well when we figure out how to do this well.
Thank you. I think there's a lot of questions, at least on this map, about the quantum workforce, so I will leave that there, and then I'm just going to open it up to questions from the audience first. If anyone has a question, feel free to raise your hand and I'll point you towards, yeah.
Oh, I don't need a microphone. I love what you're saying. I work in the Faculty of Science at SFU, and getting to the students means getting to the chairs of the different departments. And I personally find, like in chemistry, they should be learning about quantum, but we're not, right? So what has been your, the response from chairs when you talk to them about at least doing entry-level quantum courses?
We got them. We are happy to share.
In chemistry? Or
We have a second year intro course that is quantum mechanics and quantum computing information, something that would be suitable for students in chemistry. They just need linear algebra. So, happy to share. We actually had some engineers in that course.
Could we take out linear algebra? And I'm not joking about that, right? That's like an intro to quantum course, because there's all sorts of jobs to have in quantum that won't involve linear algebra.
Yes.
And that's definitely a barrier. So like something at least to get people interested.
We can produce more for different audiences.
I will just jump in and say that from a non-academic standpoint, QAI has done a fair bit of work on this. There's 2 courses they currently offer on introducing people to quantum, both from a technical and non-technical background. If you want to talk and learn more about that, you can talk to Kirk over there in the suit. But yeah, there's a bit of a movement both in academia and outside of it to bridge the gap and sort of help create this quantum workforce, whether it's coming from an academic background or whether it's people who are wanting to retrain as well. Okay, one more, yeah.
Yeah, so last night I was studying up on quantum computing on the University of TikTok because I had to prepare for the diplomacy game, and I wanted to know, I did find a baby book on quantum computing, and it taught me a lot, so.
Yeah, I've seen that one.
My question, I guess, is how, like, every time I mention quantum computing, like, especially like to my parents, they're like, what? They have no idea. Like, so many people have never even heard of it. So what would you like to say to bloggers or journalists or the media in general to get the word out, so that people even know that it exists and a little bit more about it?
I think it's true. It's tricky how to get to the people who are not looking for it, but for the ones who get curious, there are these really cool intro resources. For example, there is what I like to still give people to start with, if they're just wondering a little bit, is Quantum Country by Michael Nielsen and other colleague. It's an interactive thing on the internet. It makes you answer questions, and then the next day reminds you should do your quantum stuff, and just get into it a little bit easy, just some basics, because I think there is this barrier of quantum sounds scary to some people. We talked about that before, right? So there seems to be out there, and it's my experience if I talk to people that you're doing what? And well, that's difficult, or what entanglement. And it depends on the perspective that you take. how it is difficult or mind-boggling or not. But I think it's just like with a lot of new things, it will take a while to settle until more people have heard about it. And in the meantime, I think computing a computer is not so scary anymore, right? But it's not so long ago, at least that's how it feels for me, that it was scary to people. So it will change, but we have to make this faster this time. We have to be clever about it and push out more resources like that people see that and are not scared, but rather informed. They want to know what this is, and is this good or bad? And they will see there's a lot of good about that.
I'm actually happy when somebody doesn't know about it compared to the people that think they know about it and think it's along the lines of quantum yoga or quantum psychology or something. I think it's very fair to say this is difficult to learn and then ask people, what do you want to know? And then try to address their questions in a way that is meaningful to them. So I don't think we should follow this hype of, quantum everything, everywhere for everyone because it's easy. It's not. We have to be honest about it in various ways.
You don't have to.
Yeah, no. It's for sure an interesting question, and how to make sure it doesn't stay within a small bubble of people who know, and then because I think we have the opportunity now, as you're saying, things are changing very fast, and that's when we have to make sure everybody's on board, right? And understand, you don't have to understand all the equations, but at least understand what this is about so that you don't feel lost. I think that's an important thing too. And how to do this, I don't have the answer, but maybe just an anecdote, it's maybe a bit on the side, but just before coming here as an exercise, I thought, okay, I'll ask ChatGPT or whatever language model, right, to list me 100 most famous women in physics. To see, in principle, they have access to almost the world's knowledge, right? So it should be. It was not able to do it. It was crazy. So I realized it was not able to list 100 women in physics, 100 famous women. So I don't know what's the algorithm to define who is famous or not, but it stopped at 41, listing Marie Curie twice with her French name and then a Polish name. Right? It was mind-boggling to see that our entire humanity knowledge is not able to list 100 women and stops at 41. And it's the same for quantum, right? Indeed, things are out there if you know how to search, but if you don't know how to search, probably it's very difficult to find information. So, yeah, we have to improve on that.
Fix the ChatGPT algorithm, first of all.
Yeah.
I'm going to take one question from the app that was highly upvoted, which is, what are the short-term job prospects for quantum computing graduates? How long until there is a sustainable career path other than research at a university? Which, yeah, I was going to say, I work in industry, I do quantum, but does anyone want to answer this, or should I answer this?
Start.
Okay. I was going to say, there are opportunities that are not at university, and I'm one of them. So I work at D-Wave, and we are building quantum annealers, and we're working on some other stuff that I can't disclose. But yeah, quantum computing is happening now. There's a lot of companies besides D-Wave. There's a couple in BC even that are actively working on developing gate model quantum computing in a variety of hardware architectures. So I would say, yeah, there's opportunities now, and you definitely don't need to go through the graduate school pipeline to have these jobs. I don't have a PhD, for example. A lot of people I work with also don't have PhDs. So the field is definitely being commercialized, and it's opening up to a lot of people that are not academics to join it. So there's opportunities.
Yeah, I think more and more companies are having bigger and bigger groups, right? And so I agree with that. And there's, yeah, it's opening up at this moment. So, yes.
I think that's time as well. So we're at 11:30. So I'm going to introduce our next guest. Dr. Daniel Higginbottom, who is the assistant professor at the Department of Physics at SFU. And he's going to be talking about some initiatives at SFU.